All right, we're going to move on to now creating a line of best fit using technology. We're actually going to use Desmos, which is exciting for me because I've used graphing calculators before, like a TI-84 graphing calculator, but I haven't used Desmos to do this. So this is kind of new for both of us and kind of exciting since Desmos is a nice calculator that we can use right on the internet, and we don't need to buy something special separately. So the situation is this: the weight of ice cream sold at a small store in pounds, X, and the average temperature outside in degrees Celsius, Y, are recorded on the table. Let's go ahead and label that on the table. All right, so X is the ice cream weight in pounds. Okay, so it's essentially how much ice cream is being sold. And then the Y is the temperature, but notice it's the temperature in degrees Celsius, which is not the way we measure temperature in the United States. Typically, most of the world does measure their temperature in degrees Celsius, but we use Fahrenheit. So remember, 0 degrees Celsius is the freezing point of water. And that's the same thing as 32 degrees Fahrenheit. So there's a little conversion there that you can look up, but just keep that in mind as we're doing this, that we're talking about degrees Celsius. Okay. Number one, for this data, use Desmos.com to create a scatter plot and best fit line. Take a screenshot of the graph and paste it above. All right, well, let's see if we can make this happen. So you are going to need to open up Desmos by either using the Desmos app or doing Desmos.com. Ooh, what just happened there? Let's try that again. So using the Desmos app or just going onto Desmos.com on a browser. And what we're going to do first is we're going to put in a table. So notice the little plus sign at the top left of your Desmos screen, and you'll have the option of making a table. And the table values will have X and Y, and they'll be labeled X sub 1, Y sub 1. That'll be important for us later, I think. But let's put in all the X values first. So you can just type them in one by one. So 20, and then hit enter, a little blue enter down here. 18, enter. 21, enter. 17, enter. 21.5. Be careful with these because sometimes I've typed them in and they don't get typed in correctly. So just be careful and double check that you've got the number that you intended. So 19.5, 21, and then 18. We're going to do the same thing. So just touch the Y sub 1 column and we're going to type the same things in. So 6, 4.5, 6.5, 3.5, 7.5, 6.5, 7, and 5. Notice it makes a nice little scatter plot over on the right there, which is kind of nice for us. And notice those points look pretty linear, pretty steep, although that's part of that is because of the window, the scale that we have here. The Y scale, notice the Y scale and the X scale are very different, so we can adjust that if needed. All right, write an equation. Oh, okay, so create a scatter plot and a best fit line. All right, so the best fit line, so what we're going to do down here in number 2 is we're going to type in the best fit line, and this is how you do it. This is kind of a technical thing, so pay attention to this. All right, so we're going to do a y equals mx plus b equation, and so we're going to usually use the y, so hit y. And then in order to do a best fit line, instead of we're doing an equal sign, we're going to use, if you press the little ABC button on the bottom left of your screen there, I'm going to kind of kick this over a little bit so we get a better view right now, since we have most of what we need. All right, so let's try that again. So with the little ABC button, and you get this menu. And on the bottom, there's this little tilde. All right, on the very bottom, next to the comma and the brackets down there, there's that little tilde symbol, like a little squiggly sign that sometimes that goes above some letters in like a Spanish alphabet, like the ñ. So it's that sort of thing right there. All right, and then we're going to type in mx plus b. So we're literally going to type the letter m, and then we're going to type the letter x, but we're going to put a 1 after that. Notice that our table has x sub 1 as the x column and y sub 1 as the y column. So if you type in a 1 after the x, it will automatically put a subscript in there, which is important for us so that the calculator recognizes that we want the x values from the table to be plugged in there. All right, mx plus b, so plus b. Go back to our b again here on the alpha. Oh, I almost forgot this. And that y needs to be a y sub 1 also. So as you're doing this, go back to that y and make sure that we have a y sub 1. Just hit 1 after the y. And notice now we get a whole thing that pops up. All right, so once again, I'm kind of learning here too. So you want that y sub 1. So you hit the y and then the number 1, and it'll put that little subscript in there, and then the tilde, and then mx plus b, where the x has a sub 1 also. And that takes the data from the table and starts to do a calculation. Notice once we do that, that we do get a line of best fit that pops up. Notice how nice that line is, and that it follows the overall pattern and splits the data in half. And this literally is like probably the best line that could possibly be drawn in this situation. And so that's kind of cool. And notice it also gives us some values here. I'm just going to get rid of the screen, but gives us some value in r squared, r. We'll be talking about those. But it also gives us an m and a b. Notice that in the data here, in the little like stuff that comes up, the statistics, you get m equals 0.782051 and b equals negative 9.4375. That's literally giving you the slope of our red line, our best fit line, and the y-intercept of our best fit line. So it actually calculates that slope and y-intercept for us. All right, I want a nice picture of this. So I'm actually going to not split screen here for a second, and we're going to do a screenshot of this and bring this back over to our notes. So I'd like you to do that as well. And I actually would like to include that information there, so I'm not going to crop it all out. I kind of like that. And in fact, well, let's just keep this for now. I wonder, actually, I'm going to adjust it a little bit. So I might actually have you guys do another screenshot here. Notice what I did was essentially opened up my window a little bit bigger so that I could see where the y-intercept is. And so I kind of like that piece of it. So I'm going to take that. We're actually going to do another screenshot here. And I'm going to make the y-intercept visible here. So let's try that again. All right. So save photos. And now I'm going to come back and drop that in to our notes. Oh, that fits so perfectly. All right. I guess it's a little bit small there, but we'll be able to zoom in on it. All right, write the equation of the best fit line. All right, I'm going to zoom in on this a little bit. So remember our equation is y equals mx plus b, our slope-intercept form, and we're actually given the slope and y-intercept of our line. So our equation, and we'll round any numbers to, what, 2 decimal places. So we're going to do 0.78x, or right there. If we round that to 2 decimal places, it's 0.78. And if we round this to 2 decimal places, that will be negative 9.44, I guess. So minus 9.44. If you want to write it as y equals 0.78x plus negative 9.44, that's the same thing as subtracting. I just don't generally write plus a negative. We just know that that is subtracting, so you'll notice that we'll just write it as y equals 0.78x minus 9.44. Okay, so that now is the equation of that line. The calculator calculated it for us. And what are the values for the slope and y-intercept for this best fit line? What do these values mean in this situation? All right, so the slope is 0.78. And now remember what we've talked about the last couple days. The slope is essentially how much the y changes for every 1x. All right, it's the rise over run, but literally it's the change in y for every 1x when you have it as a decimal like that. So what's on our x? That's the ice cream weight in pounds. Okay, so for every 1 pound of ice cream sold, what is happening to the y? And the y is positive. It's positive 0.7, so the y is increasing by 0.78. And what is the unit here? It's the temperature. The temperature is increasing by 0.78 degrees Celsius. All right, so we practiced that the last couple of days. And again, the meaning of the slope is how much the y is changing for every 1x. All right, now I did go back and take a look here on the graph at the y-intercept value, which is negative 9.44. Notice we can see that on the graph also. Here it is, 0, negative 9.44. All right, so what does that mean? Well, again, the x value, on the x-axis we have pounds ice cream. That's our x-axis label. And our y-axis label is the temperature in degrees Celsius. So as we think about what that means, so that means for 0 pounds of ice cream sold, the temperature is negative 9.44 degrees. That might make some logical sense, I guess. If it's negative 9.44 degrees Celsius, that is really cold. And so you wouldn't expect a whole lot of ice cream to be sold. So I guess that makes some logical sense. All right. Number 4, use the best fit line to predict the y value when x is 10. Is this a good estimate for the data? All right, so what that means is we're going to put 10 in for x. So we're going to put 10 in for the x value in our equation and then see what the y value is. We're going to predict then what the temperature would be, or 10 pounds of ice cream, I guess, is what we were really looking at here. All right, so 0.78 times 10 minus 9.44. All right, so if you punch that in, that's just a order of operations problem here. So if you want to punch that into your calculator, so 0.78 times 10, let's try that again, 0.78 times 10 minus 9.44. I don't think that actually calced right. Let's try that one more time. 0.78 times 10 minus 9.44. Okay, You can look back at the video to see what I actually typed in the first time there. But so we have negative 1.64. Sorry for my navigation skills here. So negative 1.64 would be the predicted y value. All right, so in other words, that's predicting for an x value of 10, we have negative 1.64 for the y value. So we see that point actually right there. So that would be our point 10, negative 1.64. All right, so do we think that is a good estimate? Well, certainly that's on the line. So the line does predict that value. It's on the line. But I guess if you're thinking about it logically, all right, so 10 pounds of ice cream, if it's below freezing, negative 1.64 degrees, which is below freezing, remember 0 Celsius is freezing, would 10 pounds of ice cream be sold? I don't know. I question that, actually. Notice that this point right here is pretty far away from the rest of the points. So really, we have a question about how far over this line will be useful. Like for what x values or what pounds of ice cream will this line actually be useful? I'm not so sure that that's going to be a very accurate prediction, but that certainly seems to be the case for the line. I mean, it certainly is the value on the line. So the line does predict that value. The point is on the line. But I wonder if 10 pounds of ice cream will be sold if the temperature is negative 1.64 degrees. Again, when you're using a line of best fit, the prediction is often most useful when you're kind of within the data set. So I'd feel pretty confident if our predictions were for points that were kind of within the data set. But once we get outside of the data set, we have to be a little bit careful, because that's when we are doing something called extrapolating. So we're predicting beyond the data set. So extrapolating here and extrapolating down here as well. That would be also extrapolating. That's making predictions beyond the data set. Versus when we are within the data set and making predictions, that's called interpolating. Big words. And when you are interpolating, you're probably going to be a little bit more confident with your predictions. When you're extrapolating, you have to be careful. Maybe you're pretty confident, or maybe it doesn't make as much sense when you get pretty far outside the scatter plot points. So just wanted to bring up those couple terms because they do come up sometimes in our vocabulary in this unit.